Here are the Model 11.3 notes. This is the final page, page 7. A couple more examples. So example 8. Companies design furniture for elementary school classrooms, produce a variety of sizes for kids of different ages. Suppose heights of kindergarten children can be described by a normal distribution, n parenthesis 38.2, comma 1.8 in inches. What's the probability that a randomly selected kindergartner would be less than 3 feet tall? So here is my normal distribution. I have a mean of 38.2. I am adding 1 standard deviation, subtracting 1 standard deviation. If we're talking about a kindergartner that's 3 feet tall, first thing I've got to do is convert that to inches, because everything else is in inches. So I know 12 inches for every 1 foot. Notice my feet are going down here, so it can cancel with the feet in the numerator. I get a kindergartner that's 36 inches tall, so just a little bit to the left of my 1 standard deviation below. Here's my 36. We want our kindergartner to be less than 3 feet tall, so smaller than 3 feet. Probability, let's get this in here since I've been forgetting it, that x is less than 36. We definitely want to make sure the format is correct. 36 inches, 3 feet, same thing. In Excel, norm.dist. Here's my 36 inches, my mean of 38.2, my standard deviation of 1.8, and my normal cumulative response there of 1, or true, 0.1108118. Again, we are rounding to 4 places. I take a look at the 5th place. That is less than 5. So I get 0.1108. If we want the probability that a randomly selected kindergartner is between 36 and 40 inches, actually, you know what? We're gonna see if we can just, I wonder if this will let me do this. Oops. Oh, the magic of technology. Okay, so between 36 and 40, we are looking for this in here. So the probability that we have a kindergartner between 36 and 40 inches is going to be my norm.dist. I have 40, a mean of 38.2, standard deviation of 1.8, my cumulative of 1, minus, that's not supposed to look like parentheses there, norm.dist. Of 36, 38.2, 1.8, and again the 1. When I subtract those, I get 0.7305, which makes sense if you think back to our empirical rule. The 36.4 to 40, that is 1 standard deviation above and below. So this should be just a little bit more than 68%. As I mentioned that empirical rule, we're going to talk about this one more time. So our empirical rule says 68% of the data falls within 1 standard deviation, 95 within 2, and 99.7% within 3. Let's see what those actual values are. So within 1 standard deviation, I got norm dot s dot dist. I'm going to go back because I'm dealing with standard deviations. 1 standard deviation above, there's my cumulative 1. Norm.s.dist. Here's my 1 standard deviation below. When I plug that in, I get 0.68268,949. When we round that to 4 places, the 8 tells us that we round up. I get 0.6827, so just slightly over that 68%. Let's try 2 standard deviations. I got a norm.s.dist, 2, 1, minus norm.s.dist, negative 2, 1. Plug those in, I get 0.95449974. Again, to 4 places, I get 0.9545. So, just under 95.5%. And so our last 3 standard deviations from the mean. So 3 above, minus 3 below, again to 4 places. This one's easy, it's followed by a 0. I get 0.9973. So just slightly over our 99.7. Let's go ahead and highlight those Excel commands again. And that's it for 11.3.